Okay, addition, elimination, and substitution reactions are 3 of the 4 reactions that we're going to learn for organic reactions. And at the high school level, we just learn the basics. We don't learn all of the different chemicals that go into play. We don't have to learn all of the temperatures. We don't have to learn the multiple steps. Having said that, some of these take multiple steps to go through. But we learn the easy peasy stuff. Let's start with the easiest one, an addition reaction. Happens when a double or a triple bond is broken and something else is added. Okay, it's kind of weird because we're breaking bonds, but then we're going to add something. Only alkenes and alkynes can undergo addition reaction. You have to have the double or the triple bond. Small molecules will split into 2 pieces, and 1 or more of the multiple bonds will break, allowing new bonds to form and make a new molecule. Let's just get to the guts of it here. So if we have pent-2-ene, and we have a double bond from 2 to 3, and we add in water, and in water, I'm going to write like this. 1, 2, 3, 4, 5. It's 5. It's just 5. Okay? This double bond here is going to break. And what happens is we're going to go 1, 2, 3, 4, 5. Notice that this is where the double bond was. Okay? We're going to take this hydroxide group and we're going to bond it in place of where that double bond was. The flip side is that the double bond stretches from carbon 2 to carbon 3, so the alcohol group could go over there. And so if I draw this out, 2, 3, 4, 5, double bond. If I break this bond here, what happens is that there's an opportunity for a hydrogen bond to happen because we have this guy here floating around. And so not only do we have these 2 products, but we also have hydrogen gas. So this one here would be pent-2-ol, and this one here would be pent-3-ol. Okay? So we're going to cut this double bond, and we're going to add in the hydroxide. Two. Here I have C3H4 plus iodine. This is my reaction. And so let's draw out what C3H4 is going to look like. 1, 2, 3. I can only have 4 hydrogens on this. 1 carbon's going to have 3. 1, 2, 3. And then I can only have 1 carbon somewhere else. So this is going to look like a triple bond. We also can confirm that because we have these formulas, right? We have CnH2 2N for an alkene. And we have a CnH2n minus 2 for an alkyne. And if we look, 2 times 3 is, minus 2 is 4. So this is a triple bond. Okay, we're going to react it with iodine. And so here's our triple bond that we're going to break. And here's the bond that's going to separate there. What happens is we break this bond right here. We get C, C, and C. We end up with, we break it once. So we're down to a double bond. This carbon still has hydrogens on it. This carbon now has a free spot open, and this carbon now has a free spot open. So what do you think is joining on those spots? Iodine. One's going to go here, and one's going to go here. No, you have to break the bond, and so two spots, two bonding electrons open up, one on one carbon and one on the other carbon. The key to this particular reaction is that this is in limited amount. If it's in limited amount, it's only going to break one bond. Okay? If I was to look at this equation again, what would I get? Well, oh, not H2, H4, sorry. Right? I have two I2s now. C3H4, same thing. I put 2 there, Declan, and I crossed it off. Yeah, I know. I'm sorry. I'm going to get my same 3 carbons. This first set of iodine is going to break one bond. This second set of iodine is going to break the second bond. This carbon stays the same with H's. And now this carbon opens up with 2. And this carbon opens up with 2. And then we still have the hydrogen from before. Right? We still have to have 4 hydrogens. So iodine and iodine, and then iodine and iodine. So what happens is one bond gets the first break, and then the second break. Okay? So if we were naming this guy right here, how would we name it? What's our naming rule? What's our naming rules? We have to find the longest chain of hydrocarbons. 1, 2, di-iodo. Propene. You could do prop 1-ene, but if we don't say it, it's understood that it's on the first one. What would we say about this guy here? propane. This one tells us that we still have a double bond present. This one tells us it's a straight chain single bond hydrocarbons. You go to the nearest halide group, right? We go down our pecking order. There's a carboxyl group, an alcohol group, or an ester? No. Is there double or triple bonds in there? No. Is there halides? Yes. We go down our pecking order. Sorry, do you need a Declan? Elimination reaction now then happens when organic molecules are removed, causing the double bond to form. Okay, so an elimination is a reverse of the addition. In the addition, we break apart a double or a triple bond. In an elimination reaction, we're removing something and then a double or a triple bond forms. And so there's two ways of doing it that help with elimination. Alcohols will undergo an elimination when the alcohol is heated in the presence of a strong acid. And the alkyl halides can also undergo elimination when it's heated in the presence of a strong base. So when we look at our chemistry data booklet and we open it up roughly to the middle page, there should be a list of the acids and bases, and at the very top there should be the 6: hydrochloric, sulfuric, nitric. Help me out, that's 3 at the very top. Yeah, I'm drawing a blank. Hydriodic and perchloric. Oh, I forgot sulfuric. Can't believe that. Okay, so those 6 acids are what we call the strong acids. The strong bases are typically anything that's bonded with sodium, calcium, magnesium. Those are bonded to a hydroxyl group. Those are what we were calling our strong bases. Typically, sodium hydroxide is one that's used in examples the most because it is like the strongest base with a hydroxyl group. And so if we're going to look at butanol heated in the presence of nitric acid, so how many carbons in our main chain? And where am I putting my alcohol group? On the second one. And it doesn't matter if it's top or bottom or if it's on the one that's second from the right. I'm going to react it with, so this says in the presence of, so it needs heat. That's the delta sign in chemistry. That indicates heat when it's over an arrow. And it's in the presence of nitric acid. Okay? What happens is that we pull off this hydroxyl group. As we pull off that hydroxyl group, we have this hydrogen here still, we have this hydrogen here still, and we have these 3 hydrogens. But then when we move this hydroxyl group, a double bond will form between 2 and 3. And so this part here, this hydrogen of the HNO3, and the nitrate part of nitric acid stays in solution. Now, because it's centered on this carbon here, we can have an OR. We can put our double bond to the right, going from 2 to 3, or we can put our double bond going from the left, from 2 to 1. We still get water, as this one would have 2 hydrogens, 1, 2, and then 1, 2, 3. Okay. Let's look at another example. So this is an alcohol. This is your star 1. This is your star 2. This is alcohol. This is an alkyl halide. Because chlorine is part of group 17. It's your halide. So halides need to be done in the presence of a strong base and heat. So let's pick sodium hydroxide. So this halide is going to be what gets pulled off. So we're going to go like this. Still 3 carbons, right? 1, 2, 3 carbons. But now instead of having a chlorine here, we're going to take a hydrogen ion. And what happens is the hydrogen ion will bond with the Cl. And then the sodium and the oxygen piece, they're still in solution. Okay? So we had a hydrogen here. Whoops, a hydrogen here. This one's going to have the hydrogen as well. So this hydrogen and that chloride get pulled off, and you end up with hydrogen chloride. So addition, you're breaking a bond. Elimination, you're forming a bond. Here's the other really hard one. Substitution. These ones are easier, so you just need to be paying attention to what's going on. So a substitution is when a hydrocarbon or a functional group is replaced with a different functional group. 2 compounds react to form 2 different compounds. So what does that sound like? Sounds like a double replacement. Okay. Addition, 2 compounds react to form 1 product, and in elimination, 1 compound reacts to form 2 products. Alcohols and alkyl halides are what typically undergo a reaction. Alcohols need to react with an acid that has a halogen in it. So what's an acid that has a halogen in it? What's group 17? Yeah, or hydrochloric, or hydriodic, or hydrobromic acids. Okay. The halogen in the acid switches places with the hydroxyl group. So hydroiodic, hydrobromic. Those are all alkyl acids, halide acids. Alkyl halides need to react with a hydroxide ion, a strong one, to produce the alcohol in a substitution reaction. So essentially, hydroxide switches place with the halide. Let's look at ethanol. Ethanol is how many carbons long? 2. So an alcohol needs to react with an acid containing a halogen. And we're just going to do a replacement. We're going to take this guy off. We're going to replace it with this, or they're going to form. And the chloride is going to swap spots. Okay. And then what's our product going to be? Water. What do we call this guy? This one. 1-chloroethane. The title's already there. Okay. Not a trick question. You could just say chloroethane. Yeah. Where is it going to go? It's going to go on the first carbon when it's only 2. It is kind of redundant, but in IUPAC naming, that's what you would do. Okay, what about this guy? If I have an alkyl halide, it has to react with a strong base. Do it. It might ask you, what would you react with it? You have to know all of the pieces that go with it. And on the diploma, I've seen multi-steps where you've done like an addition and an elimination and a substitution, and yeah, fun times. Okay, what's going to happen? This bromine group is going to be swapped with or substituted with the alcohol group. And you'll be left with a bromine ion. So this is called 1-bromo cyclopentane. What do we call this one? Cyclopentanol. Do we have to put the 1-bromo in there, or the 1 for the bromo? Cycle means ring. It's benzene, where you have alternating double bonds. Okay, there's more. So far we've got alcohols need an acid halide, and alkyl halides need a strong base. Alkanes and aromatics can undergo substitution reactions as well, but they are very stable and unreactive, so you have to force it. So what we're talking about is single bonded guys and that guy. They're super stable. So we need to force it. So alkanes can undergo a substitution when considerable amounts of energy is put into the reaction. So if I started out with methane, and I reacted it, I need something else to react it with. Let's go 10 chlorine molecules, right? This is Cl2. we need to add in UV light. And it's important that it gets written on the reaction arrow and not part of the reaction itself. It's for convention. Okay. What are we going to get? We're going to get, we could get a carbon with 1 chloride. That's 1. We could get a carbon with 2 chlorides on it. That's 2. That's 3. We could get a carbon with 3 chlorides on it. 4, 5, 6. We're going to get a carbon with 4 chlorides on it. And we're also going to get what happened to all of these hydrogens as they get replaced. We get HCl as well. Okay. So if we put methane in the presence of chlorine and we add in a whole bunch of sunlight, we're going to get chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. Okay. This is actually this guy here. Fun fact. This guy has a nickname. It's called carbon tet. And carbon tet used to be used as a fire suppressant. And when I did my chemical technology, I'm just going to pause this.